Hello everyone. In the previous video we already discussed about what is analytic, entire and harmonic function. So in today's video we are going to solve some questions based on these topics that came in CSIR NET. Okay, so here is the first question from June 2011. This is a question from part B. So here the question is, if f is the complex valued function given by f of z is equals to uxy plus ivxy, and suppose that vxy is equals to 3xy square, then we have to tick on the correct answer. Okay, so we know that if a function f is holomorphic on C, then its real and imaginary part satisfy the Laplace equation. Okay, so here its imaginary part is given by v xy is equals to 3xy square. Alright, so this should satisfy the Laplace equation if f is holomorphic. So let us see whether it is satisfying the Laplace equation or not. So what is the Laplace equation? Laplace equation is del square v by del x square plus del square v by del y square is equals to 0. Okay, now let us find del v by del x, that is equals to 3y square. Now del square v by del x square is equals to 0. Now let us find del v by del y, which is equals to 6xy, and del square v by del y square is equals to 6x. Alright, now on putting these values over here, we will get this as 0 plus its value is 6x. Now this is not equals to 0. That means it is not satisfying the Laplace equation. So therefore it is not harmonic. Hence f is not holomorphic on C for any choice of u. So option 1 is correct. Alright. Now let us see another question from CSIR NET that came in December 2014. So the question is, if ux plus iy is equals to x cube minus 3x y square plus 2x, then for which of the following functions v is u plus iv a holomorphic function on C? Holomorphic function means analytic function. So a function is analytic if it satisfies the Cauchy-Riemann equation, that is partial derivative of u with respect to x is equals to partial derivative of v with respect to y, that is ux is equals to vy, and del u by del y is equals to minus of del v by del x. Okay, these are the Cauchy-Riemann equation. So we are given u, that is equals to x cube minus 3xy square plus 2x. Okay, so now del u by del x is equals to 3x square minus 3y square plus 2. Okay, now this is equals to del v by del y. Okay, so here in the question we are given 4 options for v. So we will derivate this v with respect to y, and we will check for which of the y when partially derivated with respect to y is equals to del u by del x. Okay, so let us check option A, where v is equals to y cube minus 3x square y plus 2y. Now here del v by del y is equals to 3y square minus 3x square plus 2. So this is not equals to del u by del x. Okay, now next let us check for option B. So in option B in option B, v is equals to 3x square y minus y cube plus 2y. Now del v by del y is equals to 3x square minus 3y square plus 2. Now see, this is equals to del u by del x, isn't it? This is equals to del u by del x. So therefore option B is the correct answer. Let us check option C also. Okay, so here in C, v is equals to x cube minus 3xy square plus 2x. Okay, so here del v by del y is equals to, this is 0 minus 6xy. Okay, and this is equals to, and this is plus 0. Now this is not equals to del u by del x. Okay, so here B is the answer. Okay, for being 100% sure, you can also check this equation too. Okay, by finding del u by del y and del v by del x. So here del u by del y must be equals to minus del v by del x, as it is already satisfying equation 1, that is this one. So this is the answer. Okay, and none of these options is at least satisfying this also, so therefore this is the answer. Okay, now let us see another question that came in the year 2013. So the question is, let pz and qz be two non-zero complex polynomials, then pz into qz bar is analytic if and only if. So here we are given 4 options, and out of this 4 only one is going to be correct, because this is a part B question. Okay, so here in complex analysis, a conjugate function, that is f z bar, is said to be analytic if and only if f of z is equals to constant. Okay, this is a result that we need to remember. This is analytic if and only if f of z is constant. Okay, this is a result that you need to remember. So according to this, in the question we are given that pz into qz bar, this is analytic when, so this will be analytic in any condition, say whether it is non-constant or constant, doesn't matter, because if we are taking this to be z, say if pz is equals to z, then z is an entire function, so this is analytic in the whole complex plane. Okay, so option A is discarded. Okay, so therefore, or a direct approach for this question is using this result, that is here the conjugate function is qz, so this total is going to be analytic if and only if qz is constant. So here option 3 is correct. Okay, here is another question from June 2014, but this is a part C question. So here the question is, let f be an analytic function, z equals to x plus iy, and u comma v map from r square to r be such that u be the real part of f of z and v be the imaginary part of f of z. So here in the question it's given that f is an analytic function. Okay, so any function which is analytic, it's also harmonic, that is its real and imaginary part satisfy the satisfy the Laplace equation. Okay, and the Laplace equation is given by, for real part u, it's given by del square u by del x square plus del square u by del y square is equals to 0, and for imaginary part it's given by del square v by del x square plus del square v by del y square is equals to 0. So see, this is option 1 and this is option 2, so both are correct. Okay, now let us check if any other option is correct or not. So we know that if any function is analytic, then it will also satisfy the Cauchy-Riemann equation, that is, so therefore see, option 4 is incorrect, because here this is minus and in option it's given plus. Okay, So similarly we can check for option 3 and that will come true. Okay, see option 3, that is del square u by del x by del y minus del square u by del y del x is equals to 0. So how to get this? See, when we will derive this with respect to y, okay, so on derivating this with respect to y, we will get this del square v by del y square is equals to del square u by del y into del x. Okay, and on derivating this with respect to x, we will get means this total equation. Okay, we will get minus del square v by del x square is equals to del square u by del x into del y. Okay, see, now this can also be written as del square v by del x square is equals to minus of del square u by del x del y. Okay, now adding this and this will give us what? Let us see, del square v by del y square plus del square v by del x square is equals to 0 because this is the Laplace equation. Okay, now this is also equals to, when its RHS is added, then it's equals to what? Del square u by del y del x minus del square u by del x del y. Okay, so see, here option 3 is satisfied. Alright.